Hello everyone. So today we will discuss certain boolean functions that involve some other boolean functions. That means we will discuss functions whose outputs will depend on some other functions. Okay, so for simplicity let us consider two boolean function f1 and f2 such that we have given their minterm expansion. That means we have given two functions f1 and f2 whose canonical SOP form is given. So then we have to find out the expression for f1 dot f2, and then we will find out the expression for f1 plus f2, where dot and plus are the boolean expression. Okay, so just suppose f1 and f2 both are the functions of two variables, so there will be four minterms. Just suppose the definition of f1 is like this, and the definition of f2 is like this. So we can easily find the truth values for f1 dot f2 and f1 plus f2. Okay, so in order to obtain the values of f1 dot f2, we will look at the input corresponding to these values. So if both are 0, then it will be 0. Okay, so in this way we can get the value of f1 dot f2. Similarly, we can also find the value of f1 plus f2. So in general we can say that if two function f1 and f2, if two function f1 and f2 are given in canonical SOP form, then we can directly find out the expression for f1 dot f2 will contain only those minterms which are present in both f1 and f2. So basically f1 dot f2 will contain minterms that are present in both f1 and f2. Similarly, expression for f1 plus f2 will contain all the minterms that are present in either f1 or f2. So we can also see that if whenever f1 or f2 is 1, then f1 plus f2 will be 1. So in this way we can find these two function f1 dot f2 and f1 plus f2. Okay. Okay, similarly, if the two functions are given in their maxterm expansion, that means if two functions are given in canonical POS form, then we can easily find f1 dot f2 and f1 plus f2 also. How we will find out? Just suppose f1 and f2 are given in canonical POS form. So in one way we can convert POS into SOP form for both the functions. After converting POS into SOP form, then we can rule these rules. Okay, so how to obtain the expression for f1 dot f2 and f1 plus f2? Otherwise what we can say, if the functions are in canonical POS form, then we can directly obtain the expression in canonical POS form itself. So for this table we can write f1 as f1 as sum of uh, sum of these two minterms, f1 for 2 and 3, for 2 and 3 minterms. Yes, so we can write f1 in this form. We can also write f1 as sum of product of maxterm like 0 and 1, where it is 0. Okay, similarly for f2 we can also write f2 as in SOP form. We can write minterm 1 3, and in POS form we can write maxterm 0 and 2. Okay, So in this way we can express, just suppose f1 is given in POS form and f2 is also given in POS form, then we can find these two expression SOP form. After finding f1 and f2 in POS form, sorry, in SOP form, then we can we can use rule 1 in order to find the f1 dot f2 in SOP form. Okay, after getting SOP form, we can convert it into the POS form. Otherwise we can use these two rules directly in order to find the expression for f1 dot f2 and f1 plus f2. So f1 dot f2 will contain all the maxterms that are present in either f1 or f2. Okay, so basically these two rules will be reverse for maxterm expression. Okay, so you can verify that if, in order to find f1 dot f2, so whatever minterms are present in either f1 or f2, we will include these two terms. So this is POS form, this is also POS form for f2. So f1 dot f2 will have 0 1 2, whether these minterms are present in either f1 or f2. So we can directly write this expression. Okay, so simply we can remember the rule 1, and if functions are given in POS form, then we can equivalently convert into SOP form, and then again can use the rule 1. Otherwise we can also remember, when the functions are in POS form, then for f1 and f1, for f1 dot f2, we will take all the maxterm that are present in either f1 or f2. For f1 plus f2, we will list only those minterms which are present in both f1 and f2. Okay, so these are the two basic rule to find these two expression, f1 dot f2 or f1 plus f2. Okay, okay, so in this example it is given f1 as in f1 as canonical SOP form, f2 is also in canonical SOP form. Then we have to find the expression for f1 plus f2. So according to the rule, f1 plus f2 will have the minterms, f1 plus f2 will have the minterms that are present in either f1 or f2. So we can directly write the expression for f1 plus f2 in this way. Okay, just suppose both the functions are given in POS form. Okay, so then we have to find the expression for f1 dot f2, and also we have to find the expression for f1 plus f2. If functions are given in POS form, we can use the standard result. In order to find the f1 dot f2, we will select those maxterms that are present in either f1 or f2. So we will choose the minterms that are present in either f1 or f2. Okay, so in this way we can find the f1 dot f2. For f1 plus f2, we can directly find out the maxterm which are present in both f1 and f2. So clearly this minterm 0 and 4 are present in both f1 and f2. So f1 plus f2 will have this expression. So these are the simple concept regarding how to find the functions that involves other functions. Okay, so if suppose we have given few functions that also include the don't care condition, in that case how we will find the expression for f1 dot f2 or f1 plus f2. So just suppose both the functions are given in canonical SOP form. SOP form. Also we can derive the expression if the functions are in canonical POS form. So here I am discussing only canonical SOP form when don't care conditions are present. So this is our function. It includes these two minterms and then don't care conditions, and this function include minterms and don't care condition. So I have solved here this question, so I am again writing here. Okay, so basically this is the given function. So because both the functions are of three variables, so there will be yes, so there will be 7 minterms. Yes, there will be 7 minterms. So f1 is basically uh, having value 1 for 0 and 7. So I have written here f1 is having value for 0 and 7, 0 and 7, and then it has 1 to 5 as don't care condition. So we have written 1, 2 and 5 as don't care condition. For the remaining places f1 will have the value 0. Okay, similarly f2 is given in as the minterm 0, 1, 3, 0, 1, 3 and 4 and 7 are the don't care. For the remaining places f2 will be 0. Okay, so for individual input we can calculate f1 dot f2. Okay, so if both inputs are 1, then f1 and f2 will be 1. What will be the case when one is don't care and another is 1? Okay, so we know that if any value is 1, 1 dot 0 will give 0, 1 dot 1 will give 1. So we can say that whenever we operate dot operator, yes, if we operate 1 dot operator with don't care, then we will always have don't care. Okay, so I have written here these two results. If we operate 1 with don't care, it will be don't care. If we operate 0 with don't care, so we will have 0. So these two results are basically basically from the definition of dot operator. Okay, so in this way we can complete this table. Okay, so 1 dot don't care will give don't care. Okay, so 0 dot don't care will always give 0. Okay, so 0 and 1 will be 0, 0 dot don't care will give 0, 0 and don't care will give 0, 0, 0 will give 0, 1 and don't care will give don't care. So in this way we can obtain the expression for f1 dot f2 when both the functions are given in canonical SOP form. Okay, similarly we can also fill the table for f1 plus f2. So f1 and 1 will give 1. What will happen when we operate don't care with 1 using plus operator? So don't care with 1, so it will always be the 1. Okay, there is no confusion. Whenever we operate don't care with 1, it will always give 1. What will happen if we operate don't care with 0? It will give don't care condition. Okay, so don't care with operated with 0 will give don't care conditions. So I have also written here, also I have written how to operate don't care with plus operator. Okay, 1 bit don't care will always give 1, 0 bit don't care will give don't care. Okay, we can remember or we can derive these results with the definition of dot and plus operator directly. So in this way we can fill the table. So 0 and 1 will give 1, 0 with don't care will give don't care, 0 bit don't care will give don't care, 0 and 0 will give 0, 1 bit don't care will always give 1. So in this way we can get the results. Okay, so I have written here also uh, the same results. Okay, so how we can generalize when don't care conditions are present? How we can write the expression directly for f1 dot f2 and f1 plus f2? We can make some general rule here also. So in order to obtain f1 dot f2, what we will do, we will select those minterms that are present in both f1 and f2. So in order to get f1 dot f2, f1 dot f2 will always have certain minterms and it will also have certain don't cares. How we will select the don't minterms? We will select those minterms, yes, so we will select those minterms that are present in both f1 and f2. So okay, and how we will select the don't cares? Okay, how we will select the don't care for f1 dot f2? So basically we will select the don't care from f1, yes, uh, those are operated with 1, yes. So we will include the don't care which are present in from these don't cares. We will select only those don't cares that are similar, that minterms are present here in another function. Also from these don't cares we will select only those don't cares that are present here. Okay, so you can use this standard result. Okay, so uh, we will select those minterms that are present in both f1 and f2, and we will select those don't cares. From here we have to select don't care, also we have to select don't care. We will select those don't cares correspondingly that minterm is there. Similarly, from these don't cares we will select only those don't care corresponding to that minterms are here. Okay, so again if I look into this uh, in the example 3 it is given. So okay, so f1 dot f2 will have minterms as well as don't cares. How we will select, how we will write the expression directly from these two minterms? Yes, only 0 is common in both the parts. So we will write summation 0. So we will include only this minterm. Yes. Okay, so from these don't cares we have to select the don't cares carefully. From these three don't cares we will select only those don't cares correspondingly the minterms are here. Yes. So 1 2 5 here 0 1 3. So only 1 is common, so we will write 1. Okay, from these minterms, sorry, from these don't cares we will select only those don't cares correspondingly the minterm are here. So 4707, so we will select 7. Okay, okay, so in this way we can directly write the expression. So how this rule is derived? We can easily derive this rule. Okay, so minterms, only those minterms are present where these minterms are in both the functions. So only these minterms will be selected. Also, if we operate don't care with 1, only then it will give don't care. That's why we have taken That's why we have taken only those don't cares corresponding to that. Here 1 will occur because 1.5 will give 1. Okay, similarly we can also write the general rule for F1 plus F2. Okay, so for this question, what we have given, we have given certain logic diagram, and it is taking certain inputs and it is giving some output, and then uh, all the expressions are given in canonical SOP form. Then we have to find the expression for F3. Yes, so F1 and F2 are given. F1 and F2 are ended with this gate, and then F3 is odd with this output in order to obtain F. Okay, so so here F1 is having 8, 9, 10. F2 is having 7, 8, 12, 13, 14, 15. So F1 dot F2 will have only those minterms that are common to both. So what are the common? Here only 8 is common. So we can write the output as only one minterm. Okay. So we have to find the F3. Okay. So F is having two minterms 8 and 9. So F is having two minterms. So here we are giving the function which is having only one minterm. So here we can include both, because this is OR gate. So how we will get 8 and 9 when this function will have either 9 only, or we have 8 and 9 here, because we are ORing these two functions. So if this function will have these two minterms, and then this here 8 is the minterm, so the output can be 8 and 9. But 8 and 9 okay, so it can also have 8 and 9. So from the option, if we look 9, 10, 9, 8, 1, 8, 9. Okay, so B is the correct option. So it can also have 9, 9, or 8 and 9 both. Okay. So we have to carefully analyze if any logic circuit is given which is taking input as functions, then we have to carefully analyze. Similarly, in this question, F1, these functions are, these two functions are ended with F1 and F2 are ended. F3 is odd with the output. So we have to find the function F2 here. We have to find the function F2. Yes. So okay, so we have to find the function F2 here. Okay. So F3 is having, yes, so F3 is having 1, 6 and 15 minterm. F1 is having 4, 5, 6, 7, 8. This is F1. We have to find the F2. So that when we add these two, we will get 168, 168, 8, 15. So if suppose we are ORing this function with certain function, we have to find 1, 6, 8, 15. So 1, 6 and 15 are there. So here 8 must be there, so that the output must have 8, so that the output can be 1, 6, 8 and 15. Okay, so so output must have 8 here. It can also have 6 because if 6 is there, so output will have 6. It can also have 1 and as well as 15 also. In the worst case, it can have like this, then output will be 1 6 8 15. It if both are same. So just suppose we need only 8, so I am taking this 8. It can also have these three terms also. So if we want output at 8 and we are ending these two, so how 8 must be there in order to get 8 here. Okay, so F2 can have 8 so that the output will be 8 and then this will be 8. So so from the options 4 4 6 4 6, if it will have 4 and 6, then output will be 4 and 6. We cannot get the 8, so it cannot be the option. If it is 4 and 8, we will have 4 and 8. Okay, so so again here 4 and 8 will be output. If we apply 4 and 8 with 1 6 15 8, so it cannot have this output. It will also have 4. So B cannot be the answer. So if we apply 6 and 8, 6 and 8 if we apply, so it will have 6 and 8, 6 and 8. So output will be this. So C is the correct option. Okay, so in this way we can solve the questions which are based on functions that are using some other functions. Okay, thank you.